Hello and welcome to this version of Sam Science, where we're going to be looking at the science physics equations associated with both combined and higher tier papers. So these are the equations which you need to know off by heart, and the examiner is expecting you to know the units, the SI units involved too. So hopefully by the end of the video, you should be able to memorize or know a good way of memorizing the order of the equations and being able to rearrange the equations as well. So let's get started. But before we do, physics, it's one of those, isn't it, that just, you either love it or it makes you cry. There's nothing ever in between, is there? So don't panic. You're not the only students or the only ones that struggle with memorizing the physics equations. But hopefully by the end of the video, you would be able to have an idea of how to memorize it and, the best practice that really works for you in terms of your revision. So what we're going to do is I will start off with going through the equations. I'm going to write out the triangles. What I'd like you to do each is to link up or tell me what the link is between each of the subjects within the equation. So the first one we start off with is mass GFS, which is gravitational field strength and weight. So my question to you now is, what's the link between all three of these? If you can draw out the triangle, then please do. I will also do that as well. So here's my triangle. Okay, so for this, what you should have on your triangle is you should have weight at the top. You should have, then you should have mass, and then you should have gravitational field strength. Now, don't worry too much if you get the G and the M the wrong way round, because essentially you're going to get the same answer, okay, if you're timesing it. So if the examiner, for example, asks you to work out the weight of an object, you have the mass and you have the gravitational field strength. What you're going to do is you're going to cover up W, and then you're going to do M times gravitational field strength. Okay, so now let's have a look at the SI units associated with this particular equation. So here we go, we've got weight, mass, which is M, G, which is your gravitational field strength. You can write GFS if you want to, but as you can see there, the units for mass is kilograms. If you get it in grams, please make sure that you do convert it. And then you've got gravitational field strength, which is N/kg. And we know that weight is measured in newtons because it is a force. Okay. Next equation. What's the link between force, distance, and work done? So you can either write it out as like just in words, or you can do the triangle. But as I say, the triangle is really good to help you memorize. So here's my triangle. So what you should have is you should have W at the top, should have F. There we go, F. And then you should have D. Now sometimes distance is, in terms of the symbol, it is, or it can be shown as S, lowercase s. So if you put D, that's fine. If you put lowercase s, that is also fine as well. So we've got W, which is work done, equals force times distance. Now, if the examiner wants you to rearrange it and asks you, for example, to work out the force applied, where you've got the work done and you've got the distance, cover up F, and then you do W, which is your work done, divided by distance. Okay, so let's have a look at the SI units for these. And you don't know work done, W. Now work, is really important to know that work done is energy essentially. Okay, so it's the amount of energy. So that will be joules, capital J. We've got force, which is known as newtons. Distance, as I mentioned earlier, it can be represented as a lowercase s. And distance is usually the unit for meters. Okay. Next question. What is the link between force, spring constant, and extension? So again, you can either write out in words or you could do the triangle. You could do that now. So what you should have is F false at the top. You should have K, which is your spring constant, and you've got your E. There we go. That is what your triangle should look like. Okay, so if the examiner asks you to work out the force applied, you would cover up F. I'm just going to cover that there like that. Then you do the spring constant times extension. Okay, so now let's have a look at the SI units associated with this equation. Force applied, force essentially is newtons, spring constant, which is represented with the letter K. Don't ask why it's K, it just is, just go with it. Which is N/M, which is N from the newtons and then M from the extension, because it's how far it can stretch. Okay. Okay, next question. You may have come across this in maths as well. So what's the link between distance, speed, and time? Distance, speed, and time. And again, you can represent distance with either the lowercase s or the d. For this purpose, I'm just going to stick with d because that's what I know. What you should have is d, and you should have, oh, no, not d again, s, and yes, time. Okay, that is what your equation should look like. So the examiner asks you to work out the time it takes for a cyclist traveling, say, 50 meters, going at a speed of 10 ms. What is the time, or how long does it take for them to get from A to B? What do? You're rearranging here. So you're covering up T, you're doing D, distance, divided by speed. Okay, let's have a look at the SI units associated with this. It's travelled, S, meters, speed, which is ms. So remember the symbol there is V, not to get that confused with velocity, and times by time, which is seconds. And again, if they give it to you in minutes, which they may do in the higher tier or the triple, you are expected to convert. Okay, next question. What is the link between acceleration, change in velocity, and time taken? So if you could draw out the triangle for me now, or you can write it out in words if that's what works for you. We did this in the previous video when we looked at the acceleration questions and the equations. Okay, so you should have is the change. I'm just going to put here change. And that I will explain what that means in a minute. And then A, and then time. Okay, so this is a change, you remember, in the velocity. Okay, so if I want to work out the acceleration, cover up A, then I do the change in velocity. So for example, it could be starting initial could be 0 and the final being say 10. So remember, it's final, take initial. So we know the difference between 0 and 10 is of course 10. Divide that by the time given in the question, and that will work out your acceleration. So you should know this from the previous video, which I'm sure you did all watch. So we're changing velocity. Don't be put off by this funny symbol here. Don't be put off by that. If you don't remember that, that's absolutely fine. Don't be put off by that. Okay, divided by the time taken, as we mentioned. Okay, and that simply just means the change. Okay, acceleration we know is ms2. Okay, and the change in the actual velocity is going to be ms. Time we know is seconds. Okay. Meantime, we had to put a meme in somewhere, didn't we? So, physics teacher, can someone explain what a vector is? Both magnitude and direction. Did you get that? direction, magnitude, because that's what vector is, and scalar isn't. yeah. That was a funny one, that one is. Okay, right. Let's go back to our serious talk time. Okay, so link between force, mass, and acceleration. So if I could ask you now to write me out the link or the triangle. See if you can beat me to it. Here's our beautiful triangle. Let's get that text down. So what you should have is F. So I don't know why it's lowercase, but I'm not going to change it. M and A. There we go. F equals MA. So again, if I just cover up force, I want to work out what force is. I do mass times acceleration. Okay. The examiner asks you to work out the force, not the force, sorry, asks you to work out the mass of an object, and this has a particular acceleration and a particular force. Cover up M, and you do force divided by acceleration. Okay. Let's have a look at the SI units associated with this. Okay, so you can see that it's becoming quite repetitive at the moment in that it doesn't change. Force will always be newtons, capital N. Mass will always be kg. You know, acceleration from the previous video is m/s squared. Okay. Okay, look away if you are not doing the higher content, because this is for those that are not doing foundation. You don't actually need to know this. So close your eyes for about 10 seconds if you are not doing the other papers, but you are doing foundation instead. So the mass, momentum, velocity. This is a funny one because momentum is not actually represented with an M, it's actually represented with a P, actually the symbols. M we know is mass. I don't know why it's lowercase, but I'll go with the flow there. And then there's our velocity. Okay, that's what it should look like. And again, the examiner asks you what momentum is. Cover up P, cover up what you were trying to work out, and you do M, which is your mass times velocity. Okay, and let's have a look at the SI units for this. Momentum, P, which as you can see there, kg, m/s, mass, kg, and velocity again is ms. Okay, now we've obviously got four subjects here. So the examiner could ask you, especially if you're doing the higher papers there, could ask you absolutely anything on this, especially may even ask you to rearrange it. So if you could now draw out the triangle, you should have 3 at the bottom. Let's see if I can, this might be a bit tricky for me. I'll try and fit it in there. There we go. Okay, so you should have the top, kinetic energy, KE, kinetic energy, and then you have try and squeeze it in 0.5. I'm just going to maybe put it outside the triangle just so I can fit it all of it in. Okay, then we've got mass M, and then finally you should have your speed. Now it's really important here that you know that V in this situation is not velocity, but it's speed, and that should be a small 2, so it should be squared. So we've got kinetic energy. So if I want to find out what the kinetic energy of an object is that's moving, usually in the exam they give you a moving object, say like transportation, you know, car or train or something. So what you do there is you cover up the top. Okay, then you do 0.5, so essentially half, times mass times speed squared. Okay, the trickier parts of this is when they ask you to rearrange it. So then again, you cover it up depending on what they're asking you to work out there. Okay, they're asking you to work out the mass of the object. I'm going to cover up M. So what would you do? 0.5. As you can see there, you do, sorry, the kinetic energy divided by 0.5 times whatever the speed is in the exam. Okay, so don't let the equations where it's got 4 in total put you off. Okay, it's exactly the same method. You just cover up exactly what the examiner is asking you to find out. So you always need to figure out what the subject is. What is the examiner asking you? Is it asking for the mass? Is it asking for the amount of kinetic energy? Okay, or is it asking you about the speed that it's going? Okay. Now let's have a look at the SI units associated with this equation. So kinetic energy is energy essentially, okay, which is your joules. As you can see there, it's written as capital E or K because it's energy, obviously kinetic. I always do it as KE. It's EK here, so you don't get it confused with swing constant from earlier. But I always do it KE for me. I always do it for me just to help me remind myself what I'm writing there. Okay, and then we know 0.5 doesn't have any particular units because it's just a number. Then we've got mass, which is kg, and then obviously velocity squared. A lot of students forget the squared. Okay, and if you want to do it in brackets to help you, then do that as well. Okay, and then it's ms squared. Okay. All right, this is another equation that requires you to have four different components. So we've got GPE, mass, or what's the link, sorry, between GPE, mass, gravitational strength, and then we've got the height. So let's draw this triangle out. So if you could ask, if I could ask you to now write out what the link is, or if you are now getting in the habit of drawing out the triangles, very good habit to get into, can really help you when it comes to exams. Okay, so I've got to do 4 in total now. So you should have at the top is your GPU, which is your gravitational potential energy. You've got your mass. Oh, where you gone? There you go, mass. And then you've got I'm just going to put G for short because of space. So I'll grab it. We've got GPE anyway at the top, so that we won't get confused by that. And then we've got height. Okay, so again, the examiner's asking you to work out the GPE of an object, cover it up, and then you do mass times the gravitational field strength, and then times the height. Okay, now if they're asking you to work out the mass of an object, again, cover up what the subject is, so it's mass in this case, you do GPE divided by G times the height, or the H. Okay, so it's usually, you should know that it should be 9.81. Of course, we do round that up to 10. Okay, and that is something the examiner is expecting you to know in the exam. So let's have a look at the SI units associated with this equation. So gravitational potential energy, again, energy, E. So joules, we've got mass, kg, there's field strength there, G, N/kg, and then height, yes, meters. Okay. Okay. We're going to sort of move slightly towards now electricity equations. So now the link, or what is the link between power, work done, and time? So can I ask you now to write that down, or here we go. This is 3 this time, so it should be fairly easy. Okay, so you should have W at the top, which is your work done, P, and then T. Okay, that's what it should look like. And again, cover up what you want to work out, then do P times T, which is power times time. Okay, now let's have a look at the SI units associated with this. We've got work done divided by time, and we've got it there at the bottom, W-T. Power is watts. Now, be careful of the spelling there. If you spell it as W-H-A-T, definitely going to get it wrong. Yeah, definitely going to get it wrong. If you put W-A-T, yeah, there. That was a wasted mark right there. W-A-T-T-S, all right, capital W. Work done, joules, time, second. Okay. This one here, there are no triangles for these ones. This is all to do with, it's still with, this is with the topic of energy. So this is efficiency. So if they ask you to work out the efficiency of a particular appliance, yeah, it's usually an appliance. So you do useful output energy. So useful output being the useful energy. So if you think about a light bulb, what's the useful energy of a light bulb? Of course, we want light from it. So whatever that is in joules, divided by the total. So what the total output, sorry, input could be. And you just divide that. And of course, if you're doing it as a percentage, you times that then by 100. Okay. And again, both with joules. Another equation for efficiency, which you should know as well, there's no triangle associated with this. Useful power output divided by total power output. So useful, again, being what is good from the appliance that you want. So a light bulb, again, the one energy useful power output we want is light, for example. And then you just divide that by the total, whatever the total is. Again, joules, because it's all associated with energy. Okay, now waves. So just imagine that this is you here on the waves, and you're trying to get away from the shark because you are totally getting these wave equations that, you know, you're on fire. Let's move on to serious stuff now. So the link between wave speed, frequency, and wavelength. So if you are doing it at Excel, this is paper 1. If you're doing AQA, this is paper 2. So, no, let's draw first. Okay, quick as you can then, see if you can beat me. Oh, this music's amazing, isn't it? Love it. Okay, so we should have V at the top. Then you should have F. That's not false, I don't think it's false. Now this one here is supposed to be Lambda, which is, it looks like an upside down Y shape, if you like. I obviously haven't got that on my laptop, so I'm just going to just put WL for short. Okay, so V is, we know, wave speed, F is frequency, and then WL, as I put there, as I said, it's just that's your lambda, and that's going to be a wavelength. So if I want to work out frequency, cover up F, this is rearranging, then do speed divided by the wavelength. Okay. Now let's have a look at the SI units associated with this. So MS, again, frequency is hertz, capital H, Z, wavelength, we know, is in meters, length. Think of length, distance, if you like, meters. Okay, now we're moving on to, this is now electricity. So the link between time, current, and charge flow. This is paper 1 for AQA. So I've decided to draw it, and I'm going to go with drawing it because I've started to draw it and I can't stop. So what you should have is Q, I, oh, where you gone? There you are, I, and T, which is time. Okay, again, if I want to work out what the charge flow is, I cover up Q. That's a symbol for it. Don't ask me why, it just is. So now I'll do I, current, times time. Okay, and rub that out. And we are now going to have a look at the SI units. Okay. So, charge flow, current times time. Q is coulombs, capital C. I is amps, amperes, A. T, we know, is seconds. Okay. Still on electricity. Now, potential difference, current and resistance. If I could ask you now to draw the triangle for me, or the link between these three. This is a very common exam question that does pop up. What you should have is V, which is your potential difference. And then you should have resistance, or you could have resistance here actually, and it's not the end of the world and I here. Not the end of the world if you get I and R mixed up. These two, doesn't matter if you get these mixed up, because you're always going to get the right answer. It's always good habit though to get into it. So if I want to work out potential difference, I do I times R, which is current times resistance. If I want to rearrange it and I want to work out resistance, cover up R, then I do potential difference divided by current. Okay. Now let's have a look. Potential difference is volts. I we know is amps from earlier. Resistance is ohms. Okay, this funny little shape here. Okay. Next one is power, potential difference, and current. What's the link between these three? We are nearly there, ladies and gents. There is lots of equations, and I really hope that it's not putting you off at all. Probably is, but got to do what you've got to do. Okay, so power at the top. Check your answers. Check that you've got what I've got, V. And then you should have your I. Okay, so if I want to work out power, cover up P, V, which is your potential difference, times current. Okay, right, let's have a look at the units for this. Again, it's all repetitive here. Power we know is watts, potential difference, voltage, V there, volts, sorry. Current is I, which is your amps. Okay, capital A. And yeah, remember these, you have to remember these. Okay, you can put current in brackets here. Okay, so if you feel comfortable putting it in brackets, you're more than welcome to. So I ask you now, what's the link between power, current, and resistance? Power, current squared, I should say, and resistance. If I could ask you to write that out now, or draw the triangle. So what you should have is power at the top, which is your capital P. Then you should have I. Now that 2 is squared, and I can't make it smaller, so I do apologise, but it's supposed to be I squared. Okay, and then resistance here. So remember, when we square it, we're timesing it by itself, or we're just pressing the squared button on our calculator. Okay. So if I want to work out the power, cover up P, and I do current squared times resistance. Okay. Right, let's have a look at the SI units. There we go. Again, same thing. Power we know is watts. Current squared, again, it still is amps. And then we know resistance is the ohms symbol. Okay. Next question, still on electricity. So what's the link between power, energy transferred, and time? Power, energy transferred, and time. What you got? What you got, Sam fans? What you got? You got what I got? Let's have a look. E at the top. P. T. PET. It's a good way that I remember it. It's PET. P-E-T. PET. So I want to work out energy transferred, so I cover up E, and I do P, power times time. I want to rearrange it, work out power, for example. They'll always give you the 2 numbers, 2 or 3 numbers. They usually always will give you about 2 numbers. Sometimes I might chuck in a third one to confuse you, to make things a bit difficult. Okay, but as long as you know the units, you know the energy transferred is joules, T is seconds. They give it in minutes, you convert it, then you know what it is you're looking for. Cover up P, I want to work out what power is, do energy transferred divided by time. Okay, let's have a look at these SI units. Energy transfer, joules, power is watts, time, as we say there, is seconds. Okay, next question is, what's the link between energy transferred, charge flow, and potential difference? So, sound fans, let's see your triangles. If you're not a sound fan yet, you will be at the end when you're thanking me. Okay. So what you should have is, check your answers, please. E, which is your energy transferred. Q, which is charge flow. Remember, Q is a funny one for charge flow. Again, don't ask me why. And then we got V, which is your potential difference. So rearranging, if I want to work out what charge flow is, cover up Q, and I do energy transfer divided by the potential difference. Okay, there we are. Now, let's have a look at the SI units associated with this. Here we go. Energy transfer, joules, charge flow, coulombs, V, volts. Okay. Okay, this is now density, mass, and volume. So this should be fairly simple. So what is the link between density, mass, and volume? Okay, so this is moving on to the particle model now. Okay, so we come off electricity. So you should have is mass at the top. Then you should have P. That is supposed to be your density. If you feel comfortable doing D for density, but then obviously, of course, don't get that confused with distance that we talked about earlier. It's all to do with what you remember. If you forget that P is density, or previously P is momentum, do you know what? Just go with what you remember. Don't make life difficult for yourself. It really is difficult as it is. So just don't give yourself any more drama. So there we go. Now, if I want to work out what density is, cover up D. There's no D here. We're talking about cover up P. Do mass divided by volume. Okay. So let's rub this out and let's have a look at. So here we go. Density, as you can see there, is kg/m3. Mass, we know, is kg. Volume, I haven't covered this yet, but it's m cubed. Okay, or m3. Okay. Last one. Okay, this is for physics only. Look away if you're doing any other paper. This, I haven't done anything really in terms of working it out there, but this is the triangle for pressure. Okay, so to work out pressure, again, we've got pressure here. I'll cover up P. I'm going to do the force, which you know the unit is newtons, divided by A, not to get that confused with anything else in terms of electricity, amps or anything, because we know that current is I anyway. So we cover P, and we do force divided by the area of the surface, so surface area. Okay, as you can see there, pressure is Pascal, named after the famous scientist Pascal, but we shorten it to PA. Okay, surface area is m squared, and you know the force, doesn't matter what it is, force, always be measured in newtons. Okay, so sound fans, that is the end of the video. So hopefully you would have now gained a better idea of how to note down and revise for these physics equations, and be sure to check out our next video, which will be physics related, but not too sure what that would be. But yes, please do go back through the video, pause at any point if you feel that you need to go over anything in particular. These triangles are very, very handy to put on for flashcards, and then you can just read them off from there. Thank you very much, Sim fans.